Welcome to these gentle, soothing stories for sleep. I'm so glad you are here. Whether you are preparing to drift off to sleep, relaxing after a long day, or simply seeking a quiet companion, you have come to the right place. Tonight, we will begin a long journey together, a story about what might happen when humanity says goodbye to its first home and sets out for the red shores of Mars. Before we begin, I would love to know where you are listening from tonight, or perhaps just how your day was. Please feel free to leave a gentle comment below. Wherever you may be, I hope you are feeling comfortable, safe, and ready to explore something truly extraordinary. And if you find this journey to be a peaceful one, please consider liking this video and subscribing to our channel. It helps other souls who are searching for quiet comfort to find their way here. Imagine the feeling of sand between your toes for the very last time, not just for the day or for the year, but forever. The grains are warm from the long afternoon sun, a familiar, comforting roughness against your skin. You are standing on the shore of an ocean whose name is now a prayer on the lips of everyone you know, watching the waves roll in, each one a soft, percussive whisper against the land. This sound, the oldest and most constant rhythm of our world, is a lullaby you are hearing for the last time. The air is thick with the scent of salt and damp earth, a perfume brewed over billions of years of life. And as you breathe it in, your lungs ache with a kind of love that is so deep it feels like grief. The sun is sinking toward the horizon, a great, swollen orb of liquid gold, and it begins to paint the underside of the clouds in impossible shades of rose and violet. This is the last sunset you will ever see on Earth, and because you know this, you see it with a clarity that is almost unbearable. Every detail, every shift of light, every fleeting color is being etched into your memory, because soon, memory is all you will have of this place. This moment is not just an ending. It is a profound and aching farewell to the only home our species has ever known. A final, silent conversation with the world that made us. The reason this final sunset holds such a heartbreaking palette of colors, the deep reds and burning oranges, is because of a gentle and beautiful piece of physics happening in the very air you are breathing. The light from the sun, which appears white to our eyes, is actually a beautiful spectrum of all colors, a rainbow bundled together. You can think of these colors as tiny travelers of different energies. The blue and violet light travels in short, skittish waves, while the red and orange light travels in long, confident, rolling waves. Our atmosphere is a vast ocean of nitrogen and oxygen molecules, and as the sunlight journeys through it, these molecules act like a magnificent, invisible filter. They are especially good at scattering the short, jumpy waves of blue light, tossing them around the sky in every direction. This is why, on a clear afternoon, the sky above us is a brilliant, welcoming blue. It is the color of sunlight scattered and shared across the entire dome of the heavens. But as the sun sinks to the horizon at sunset, its light must travel through much more of the atmosphere to reach your eyes. It is a longer, more difficult journey. On this long path, most of the blue light is scattered away, lost to the sides, so that only the long, persistent, resilient waves of red, orange, and gold can complete the journey straight to you. You are seeing the light that endured. The colors of a sunset are the colors of survival, the ones that made it all the way through the deepening air to say one last goodbye. As you stand there, watching the last sliver of fiery light dip below the curve of the world, you might notice that your senses feel impossibly sharp. The sound of the waves is clearer, the salty air is richer, the warmth of the sand more profound. This heightened awareness is a strange and tender gift from your own mind, a psychological phenomenon known as anticipatory grief. It is the process of mourning something before it has truly gone. Your brain, in its deep and ancient wisdom, understands the magnitude of this departure. It knows that you are about to lose not just a place, but an entire sensory world. And so, it begins the work of grieving in advance, and in doing so, it turns up the volume on all of your senses. It is trying to capture and record everything it can to create the most vivid and detailed archive of home before the connection is severed. It is a final, desperate act of love, your own consciousness trying to hold on to the warmth of the sun, the sound of the ocean, and the feeling of home, knowing that the cold silence of the void awaits. It is a beautiful and painful paradox. The sorrow of leaving is what makes these last moments on Earth more intensely alive than any you have ever experienced before. And as the darkness deepens, another layer of this world's embrace makes itself known, not to your senses, but to your understanding. It is the vast, invisible shield of our planet's magnetic field, the magnetosphere. For your entire life, this silent, protective bubble has been defending you from the harsh radiation of the sun and deep space, like a warm and gentle blanket, deflecting cosmic winds and preserving our precious atmosphere. We have lived and dreamed and loved under this invisible grace for all of human history, and now we are about to leave it behind, to sail out from this safe harbour into the deep and unprotected ocean of space. The last true light of the sun has vanished now, and the sky is a deep, bruised purple. A new light begins to assert itself overhead, not a star, but a steady, brilliant point of white. It is the vessel, your new home, waiting in the high quiet of the upper atmosphere. It is a light that does not promise warmth, but a journey. It is pulling you away from the sunset and towards a new dawn, one that will rise over a different world, a world governed by entirely different and unforgiving laws. Can you feel the weight of the sky? It is a strange question, because we have lived under it for so long that we do not perceive it as a weight at all, but simply as the state of being. Yet, the atmosphere above you, this ocean of air, is pressing down on every square inch of your body with a force of about 14.7 pounds. It is a constant, steady, life-giving embrace that we have always taken for granted. To leave Earth, to truly depart from its surface and begin the journey to another world, is to fight against that weight and against the even more powerful, invisible tether of gravity itself. The journey does not begin with a gentle drift, but with an act of immense and controlled violence. Strapped into your seat, deep within the metallic heart of the launch vehicle, the world is reduced to the quiet hum of electronics and the soft sound of your own breathing. Then, a low rumble begins, a vibration that you feel not in your ears, but in the marrow of your bones. It grows exponentially, becoming a deafening, chest-compressing roar that seems to consume all of reality. You feel a colossal hand pressing you down into your seat, the force of acceleration, the famous G-force, multiplying your own weight again and again. It becomes difficult to breathe, to lift a hand. You are no longer a person, but a passenger, utterly surrendered to the awesome power of a controlled explosion. Outside the small, thick porthole, the familiar blue of the sky flashes past, thinning with impossible speed, deepening to indigo, then to violet, and then, in an instant, it is gone, replaced by a blackness so profound and absolute, it seems to have substance. The roar of the engines is the sound of humanity, shouting its defiance at the heavens, and the crushing weight is the price of admission to the cosmos. This titanic struggle against Earth's embrace is dictated by an elegant but unforgiving piece of mathematics known as the Tsiolkovsky rocket equation. First derived by the brilliant Russian scientist Konstantin Tsiolkovsky over a century ago, it is the fundamental law that governs all space travel, and it is a harsh master. The equation reveals a difficult truth. To go faster, a rocket needs more fuel. But that fuel has mass, which makes the rocket heavier. And a heavier rocket requires even more fuel just to lift the initial fuel off the ground. It is a cycle of diminishing returns, a challenge that escalates with every pound you wish to carry into space. You can imagine trying to throw a baseball high into the air. Now imagine that for every extra foot you want the ball to travel upwards, you must add an ounce of weight to the ball itself. Very quickly, the ball becomes too heavy to throw at all. This is what engineers call the tyranny of the rocket equation. It is why the launch vehicles we build are so colossal, so overwhelmingly massive compared to the tiny capsules at their very tips that carry the astronauts. The vast majority of a rocket, often more than 90% of its entire mass, is just fuel, destined to be burned and discarded in the first few minutes of the flight, all for the singular purpose of pushing the remaining few percent ever faster. It is a testament to the sheer difficulty of leaving home, a mathematical proof of how desperately Earth's gravity wants to keep us here. The entire purpose of this thunderous, fuel-consuming ascent is to achieve a very specific number, a speed that acts as a key to a celestial door. This is known as escape velocity. For a planet like Earth, that speed is approximately 11.2 kilometers per second, or about 25,000 miles per hour. It is a mind-boggling speed, fast enough to cross the entire United States in about 5 minutes. But it is not about distance, it is about energy. Imagine you are rolling a ball up a very long hill. If you do not push it hard enough, it will roll for a while, slow down, and then roll back to you. Gravity always wins. But if you can push it with enough initial speed, it will crest the top of the hill and be free to roll down the other side. Escape velocity is the speed needed to crest the top of Earth's gravity hill. If your vessel reaches this critical speed, it will have enough momentum to overcome Earth's relentless pull and coast away forever, never to fall back. Anything less, and you are simply in orbit, still captured, still dancing with the planet that holds you. The raw power needed to achieve this comes from one of the most fundamental laws of the physical universe. Newton's third law of motion. For every action, there is an equal and opposite reaction. A rocket does not push against the ground to fly. It flies by throwing a part of itself away with tremendous force. The engines expel hot gases downwards at incredible speeds, and in reaction, the universe pushes the rocket upwards with precisely the same amount of force. It is like standing on a skateboard and throwing a heavy bowling ball behind you. The act of throwing the ball pushes you, and the skateboard, forward. The rocket is simply doing this millions of times a second, throwing its own mass away in a continuous, controlled torrent to buy its freedom from the planet. The violence of our departure, the sheer, world-shaking power it requires, is in its own way a beautiful tribute to the world we are leaving. It is a measure of the strength of Earth's hold on us, a physical expression of the bond between a planet and the life it has nurtured. We do not slip away gently in the night. We must tear ourselves away from its grasp. And then, as the final stage of the rocket burns out and falls silent, the transition is breathtaking. The bone-shattering roar ceases, replaced by a silence so deep it feels like a presence in itself. The crushing weight on your chest vanishes, and in its place comes a floating, effortless freedom. The dust motes in the cabin air, kicked up by the vibrations, hang suspended in a gentle slow-motion ballet. You are weightless. You have done it. You have paid the price. You have obeyed the tyrannical equations, and you have passed through the celestial door. You are floating in the quiet void, but you know, with a sudden and profound clarity, that this gentle freedom is a fragile illusion, and that your body, an instrument tuned only for the song of Earth, is about to begin its own silent rebellion against the quiet of this new and endless sea. What happens when the only home you have ever known becomes a marble in a velvet box? After the thunder of departure and the struggle for escape, a profound and unshakable quiet settles over the journey. The engines fall silent, their great work done for now, and the ship becomes a vessel of pure momentum, coasting in a long, silent arc through the solar system. Inside, the world is a small, predictable bubble of recycled air and soft, artificial light. The hum of the life support systems becomes the new baseline of existence, a gentle, electronic reassurance that you are alive in a place where no life should be. But your attention is not on the sterile interior. It is drawn, magnetically, to the window. There, suspended in the deepest black imaginable, is the Earth. It shrinks by the hour, the familiar continents of green and tan receding, the brilliant blue of the oceans deepening, the swirl of clouds becoming a delicate porcelain glaze. It is no longer a world, a place of nations and forests and oceans, but an object, a perfect, sunlit jewel hanging in the void. You are watching your entire world, every person you have ever known, every memory you have ever made, every war ever fought, and every poem ever written, dwindle until it is a beautiful, fragile bauble that you could cover with your thumb. And in that moment, something inside your mind shifts, irrevocably. This powerful cognitive change, this sudden and overwhelming sense of perspective, has a name. It is called the overview effect. It has been described by nearly every astronaut who has had the privilege of seeing our world from a distance. On the ground, it is so easy to feel that our divisions are vast and our problems are all-encompassing. The borders on our maps seem so real, our conflicts so important. But from space, all of that melts away. The atmosphere, which seems like an endless sky from below, is revealed to be a film of blue light, so thin and delicate, it looks like it could be wiped away with a fingertip. The interconnectedness of everything becomes obvious, not as an idea, but as a visceral, emotional truth. You see the planet as a single, living system, a shared and fragile vessel for all of humanity. It is a feeling of profound connection, a sense of belonging not to a country or a creed, but to a planet. And as you drift further away, this feeling becomes tinged with a deep and protective tenderness. The Earth is seen for what it is, an impossibly precious oasis of life in an overwhelming, sterile emptiness. This perspective is the first great, unexpected gift of the journey, a psychological transformation that reshapes your understanding of home and your place in the universe. But the mind, even as it expands with this new perspective, is also being challenged by the nature of the journey itself. You are confined to a small, unchanging space, traveling through an environment that is almost entirely devoid of sensory input. The view outside, while magnificent, is static. The stars do not twinkle. They are hard, unwavering points of light against a black that does not change. This profound lack of novelty can have a strange effect on the human brain. Our consciousness is a novelty-seeking machine. It thrives on new sights, new sounds, new experiences. When it is deprived of them, it can begin to feel untethered. Your perception of time might begin to warp. Hours can feel like minutes, or minutes can stretch into an eternity, with no sunrise or sunset to mark their passage. Your brain, hungry for stimulation, might even begin to create its own. You might find yourself lost in daydreams of incredible vividness, or experience moments where the boundary between memory and the present moment begins to blur. It is a gentle form of sensory deprivation, a reminder that our minds were shaped by the rich, chaotic, ever-changing environment of Earth. We are creatures of the weather, of the rustling leaves, of the unpredictable patterns of life, and in this sterile perfection, our minds must learn to navigate a new kind of inner world. And as the distance grows, a more fundamental connection begins to stretch and thin. The connection of communication. The speed of light, the fastest thing in the universe, is a constant, at just under 300,000 kilometers per second. This seems instantaneous in our earthly lives, but in the vastness of space, it becomes a noticeable and then a significant delay. In the first days of the journey, a message to Earth and the reply might have a lag of a few seconds, a slight but manageable pause. But as your vessel sails further into the void, that delay grows. Soon, it is minutes. You send a question, and you must wait 5, then 10, then 20 minutes for the answer to begin its long journey back to you. A conversation becomes an exchange of letters. The thread of real-time connection is stretched until it breaks, and you are no longer a part of the immediate, ongoing story of Earth. You are living in its past, and it is living in yours. This light lag is more than a technical inconvenience. It is a profound form of isolation, a constant reminder of the expanding gulf of emptiness that separates you from everything you have ever called home. We travel through this great ocean of emptiness to reach another world, but we find that the journey forces us to explore the even more vast and mysterious territories within our own minds. And while our consciousness grapples with this new and lonely perspective, our bodies, in the quiet of the ship, are beginning a silent, invisible rebellion against the very nature of this journey. Have you ever truly felt your own bones? Not just their hardness against a fall or the ache of a long day, but their deep, abiding purpose. Your skeleton is the scaffold of your being, the strong and silent partner that has spent every moment of your life in a constant, heroic struggle against the force of gravity. It is what allows you to stand, to walk, to reach for the sky. It is a structure born of and for the Earth. And now, in the persistent, gentle freefall of deep space, that purpose has been taken away. The first few days of weightlessness might feel like a magical liberation, a dream of flight made real. You float through the cabin with the slightest push of a finger. Heavy equipment can be moved with effortless grace. But this grace has a hidden cost, and your body, in its deep biological wisdom, begins to notice the change almost immediately. You might feel a strange puffiness in your face, or a persistent stuffiness in your nose, as the fluids in your body, no longer pulled down toward your feet by gravity, redistribute themselves evenly. The world feels soft, cushioned, and devoid of impact. And in this soft, new world, your bones begin to whisper to one another that their long, hard work is over. This is not a poetic idea. It is a straightforward biological reality governed by something called Wolff's Law, which states that bone in a healthy person or animal will adapt to the loads under which it is placed. Your bones are not static, inert objects like the steel frame of a building. They are living, dynamic tissue, constantly breaking down and rebuilding themselves in a process called remodeling. On Earth, every step you take, every object you lift, sends a tiny stress signal through your skeleton, and your body responds by reinforcing the bone, making it stronger where it needs to be. It is a perfect system of supply and demand. But in microgravity, there is no demand. The constant, weight-bearing stress that signals the need for strong bones is gone. The body, being an incredibly efficient and unsentimental machine, interprets this lack of signal as a sign that a dense, heavy skeleton is no longer necessary. It is like a company's head office noticing that a remote branch is doing no work, and so it begins to downsize, reallocating those resources elsewhere. Your body begins to reabsorb the calcium and minerals from your skeleton, and your bone density starts to decline at an alarming rate, as much as 1 to 2% per month for astronauts on long-duration missions. A year in space can lead to a decade's worth of age-related bone loss on Earth, and where the bones lead, the muscles must follow. Your entire musculature, particularly the large, powerful anti-gravity muscles of your legs and back, is designed for the constant, low-level workout of simply existing on Earth. Just sitting in a chair, your muscles are subtly firing to keep you upright. Without this constant resistance, they too begin to atrophy. The principle is simple. Use it or lose it. The lack of gravitational load is like being on permanent, full-body bed rest. Even with the rigorous, multi-hour exercise regimens that all astronauts undertake, using resistance bands and specialized treadmills to simulate weight, it is a constant, uphill battle against the body's own drive for efficiency. The heart, a muscle itself, also changes. On Earth, it has to work hard to pump blood uphill to your brain against the pull of gravity. In space, that resistance is gone, and the heart can shrink in size and strength, adapting to its new, less demanding job. Your body is, in essence, unraveling itself, deconstructing the earthbound form it no longer believes it needs, and beginning a slow, silent transformation into a creature of the void. This internal unraveling is happening within a vessel that is itself besieged by an invisible threat. Back on Earth, we were protected by the planet's magnetic field and thick atmosphere, a multi-layered shield against the harsh radiation of the cosmos. Here, in deep space, that shield is gone. The ship is constantly being bombarded by two types of radiation. The solar particles from our own sun, which can surge during solar flares, and the more insidious galactic cosmic rays, or GCRs. These are the atomic nuclei of long-dead stars, remnants of ancient supernovae that have been accelerated to near the speed of light and now crisscross the galaxy. You can think of them as relentless, microscopic bullets. They are so energetic that they can pass straight through the hull of the spacecraft and through the human body. As they do, they can strike and damage the delicate strands of our DNA, causing mutations that can accumulate over time, increasing the long-term risk of cancer and other diseases. The ship's hull and its internal layout provide some shielding, but the danger is a constant, ambient presence for the entire duration of the journey. Our bodies, these exquisite instruments, perfectly tuned for the gentle conditions within Earth's protective embrace, are now revealed for what they are. Fragile vessels, drifting through an environment that is fundamentally hostile to their very structure. To survive this journey, we must become the vigilant custodians of our own biology. But even that is not enough. To reach our destination, we must also become masters of the silent, celestial clockwork that guides our long and falling path through the dark. How do you navigate a sea with no water, no wind, and where the safest path is a fall? For months on end, this is the reality of your journey. After the initial, violent surge that freed you from Earth's gravity, the engines have fallen silent. There is no sensation of movement, no hum of propulsion, only the quiet, life-sustaining thrum of the vessel around you. Yet you are hurtling through the void at tens of thousands of kilometers per hour. The journey has become an act of profound patience, a long and graceful coast through the darkness. Your ship is now less a vehicle and more of a tiny, man-made, celestial body, a temporary moon of the sun, caught in its immense and invisible gravitational field. The navigation is not one of steering, but of timing. It is a dance that was choreographed decades ago by astronomers and physicists, a silent waltz with the fundamental laws of the cosmos. Outside the window, the stars are a fixed and frozen panorama, unblinking in the vacuum, and against their backdrop, your ship follows a long, curving, invisible path, a road paved only by mathematics and gravity. This is the quiet, patient heart of the journey, a long surrender to the elegant clockwork of the solar system. The path you follow is not a straight line from one planet to another. To travel in a straight line would require an unimaginable amount of fuel, constantly firing your engines to fight the sun's gravity. Instead, you are taking the most energy-efficient route possible, a beautiful, arcing trajectory known as a Hohmann transfer orbit. It is the celestial equivalent of a driver merging gracefully onto a highway. Back at Earth, your ship fired its engines in a powerful but brief burn. This did not point you toward Mars, but instead, it pushed you into a new, larger orbit around the Sun. It was like moving into a faster, wider lane on our cosmic highway. For the next several months, you simply coast along this new elliptical path, your ship rising further and further from the Sun, carried by its own momentum. You are, in the most literal sense, falling. The genius of this path is that its highest point, its farthest reach from the Sun, has been precisely calculated to intersect with the orbit of Mars. The timing must be perfect. You have to leave Earth, not when it is closest to Mars, but months earlier, aiming for a point in empty space where you know Mars will be when you arrive. Then, as your vessel finally approaches the red planet, you will fire your engines a second time, not to speed up, but to slow down, allowing the gravity of Mars to capture you and pull you into its orbit. This is the art of interplanetary travel, not a battle against gravity, but a clever and respectful use of its power. While your journey to Mars relies on this simple, elegant transfer, celestial navigators have other tricks they can use for more complex journeys. One of the most beautiful is the gravity assist, or gravitational slingshot. It is a way for a spacecraft to steal a tiny amount of a planet's immense orbital energy to change its own speed and direction. Imagine a skateboarder rolling past a much larger, faster-moving bus. If the skateboarder can grab onto the back of the bus for just a moment, they will be flung forward, gaining a significant speed boost. A spacecraft does the same thing with a planet. By flying close behind a planet in its orbit, the spacecraft is caught by the planet's gravitational field and whipped around it, emerging with more speed than it had before. It is a cosmic pirouette, a free and powerful acceleration provided by the universe itself. This is how probes sent to the outer solar system, like the Voyager spacecraft, were able to reach Jupiter, Saturn, and beyond without carrying impossible amounts of fuel. All of these maneuvers, the long coast, the slingshot, the orbital insertion, are governed by a profound and often misunderstood truth. You are in a constant state of freefall. The feeling of weightlessness you experience is not because you have escaped gravity. The sun's gravity is still powerful out here, as is the distant but still present pull of Earth and the other planets. The reason you float is that your ship, your body, and everything inside it are all falling together at the exact same speed. Albert Einstein explained this with a beautiful thought experiment. Imagine you are in an elevator and its cable suddenly snaps. For the few terrifying seconds before it hits the ground, you and the elevator would be falling together. If you were to let go of a pen, it would float in front of you, seemingly weightless, because it is falling at the same rate you are. Your spacecraft is that elevator, and it is in a permanent state of falling around the sun. Weightlessness is simply the experience of a shared, continuous fall. And so you spend your months in transit, surrendering to this great cosmic fall, trusting in the ancient laws of motion and gravitation written into the fabric of the universe. And after an eternity of this silent, patient, falling dance, a new star begins to grow in the blackness ahead. At first a pinprick, then a tiny disk. It slowly resolves itself into a world. A rusty, butterscotch-coloured globe that promises an end to the falling and the beginning of a new kind of standing. What colour is the sky on a world without a blue ocean to reflect? This is the question that fills your mind as your lander separates from the main vessel and begins its fiery descent. The long, quiet coast is over, and for the first time in months, you feel a sense of direction, of down. The heat shield on the outside of your capsule begins to glow, a brilliant, incandescent orange as it compresses the thin upper wisps of the Martian atmosphere, converting your colossal orbital speed into thermal energy. The ride is rough and jarring. You feel the deep thud and pull of the parachutes deploying high above you, slowing your plummet. Finally, in the last few hundred meters, the landing engines ignite in a final, precise burst of power, kicking up a vast cloud of fine, red dust from the surface below. And then, with a gentle, almost anticlimactic bump, you are down. The engines cut out, and a silence more profound than any you experienced in deep space descends upon you. It is the silence of a world that has been waiting for 4 billion years. You hold your breath and look out the window. Before you lies a landscape of staggering and stark beauty. A vast, undulating desert of red sand and ochre rocks stretches to a soft, curved horizon. And above it, the sky is a colour you have never seen before. It is not the deep, comforting blue of home, but a delicate, hazy, pinkish tan, like pale butterscotch or faded salmon. It is the first light you have seen on a new world. The strange and beautiful colour of the Martian sky has an explanation that is, in a way, the opposite of why Earth's sky is blue. Our homeworld's sky is blue because the nitrogen and oxygen molecules in our dense atmosphere are very good at scattering short-wavelength blue light. The Martian atmosphere, however, is incredibly thin, less than 1% the density of Earth's. It does not have enough gas molecules to effectively scatter light in the same way. But what it does have is dust. The air on Mars is permanently filled with tiny, microscopic particles of iron oxide, which is, quite simply, rust. This fine, red dust hangs in the atmosphere like a permanent, planet-wide haze. And these dust particles are much larger than air molecules, so they behave differently with sunlight. Instead of scattering blue light, they tend to absorb the blue wavelengths and scatter the longer, redder wavelengths of light. So when you look up at the Martian sky, the pale, pinkish light you see is the glow of sunlight being scattered across the heavens by countless particles of rust. It is the colour of a world that has been slowly oxidizing, slowly breathing in its own way, for eons. This thin veil of an atmosphere is the defining feature of the Martian environment. To stand on the surface of Mars without protection would be like being instantly transported to an altitude of over 30 kilometers, or about 100,000 feet. On Earth, far higher than any mountain, deep into the stratosphere. The atmospheric pressure is so low that your body's liquids would, in a very real sense, begin to boil, even at the cold ambient temperature. The saliva on your tongue, the tears in your eyes, the very water within your cells would try to turn to gas. This is why liquid water cannot exist for long on the surface of Mars today. If you were to pour a cup of water onto the ground, the low pressure would cause it to rapidly boil and sublimate, turning directly into vapor and vanishing into the thin air, even if the ground was frozen. The air itself is almost entirely carbon dioxide, about 96%, with only trace amounts of the oxygen we need to survive. It is an alien sky in every sense, beautiful in its desolation, but utterly hostile to unprotected life. The reason for the red dust in that sky, and the red ground beneath your feet, is the same. Mars is a rusted planet. Its surface rocks and the fine soil, called regolith, are incredibly rich in iron. Billions of years ago, Mars was a warmer, wetter world. It had rivers, lakes, and perhaps even oceans, under a thicker atmosphere. During that time, the abundant iron in its crust reacted with water and traces of oxygen, and it oxidized. The entire planet, over geological time, rusted. The red world before you is a fossil, a planetary relic of a time when it was much more like Earth. And now, you are here. For the first time in the history of the universe, a creature born of the blue and green world of Earth is standing on the red and ancient world of Mars. Humanity is the alien. We are the visitors stepping into a realm that has been governed only by physics and chemistry for billions of years. Every footprint you will leave on this dusty surface will be a mark of impossible significance. The first intrusion of biology into this silent, sleeping world. The first breath you take here will be of manufactured air inside your helmet, a bubble of a distant, living world. But the first step you take will be a negotiation with a force you have always known, but which is now a gentle and deceptive stranger. The force of gravity. Imagine waking up one morning and feeling that a third of your weight has simply vanished. This is not a dream, but the first and most profound physical reality of life on Mars. As you take your first steps onto the red soil, clad in the protective layers of your spacesuit, your body is a library of terrestrial memory. Your brain expects a certain resistance from the world, a familiar downward pull that has governed every movement you have ever made. But that pull is now gentle, a suggestion rather than a command. You push off with your foot to walk, and find yourself lifting into a slow, graceful, loping bound. You hang in the air for a fraction of a second longer than you should, a moment of suspended animation before your boots settle softly back into the fine, red dust. The dust itself, kicked up by your movement, seems to linger in the thin air, reluctant to fall. Your arms, your legs, your very head feel impossibly light, as if you are moving through water. The heavy, cumbersome suit that was a burden on Earth now feels manageable, its weight muted by this new, weaker grasp of the planet beneath you. It is a feeling of extraordinary buoyancy, a slow-motion ballet on a world that does not hold on to things quite so tightly. This newfound lightness is a direct consequence of Mars's smaller size. Its gravity is only about 38% as strong as Earth's. The force of gravity, as the great Isaac Newton first described, is a dance between mass and distance. A more massive planet, like our Earth, exerts a stronger gravitational pull on the objects near its surface. Mars, being significantly smaller and less dense, simply has less mass with which to pull. It is like the difference between the pull of a large, powerful magnet and that of a smaller, weaker one. Your own mass, the amount of stuff that makes up your body, has not changed at all. But your weight, which is simply the measure of gravity's pull upon that mass, has been reduced by nearly 2/3. This fundamental shift in the physical rules of existence sends a cascade of confusing signals through your body, and your brain must begin the difficult work of relearning the world from scratch. The first and most disorienting challenge is to your sense of balance. Deep within your inner ear, you have a miraculous biological instrument called the vestibular system. It helps you perceive your orientation in space, which way is up, whether you are moving or standing still, and keeping your balance. It works partly through tiny, dense crystals called otoliths that rest on microscopic hairs. On Earth, gravity constantly pulls these crystals down, and the signals they send to your brain are what give you your unshakable sense of down. But in the weak gravity of Mars, these crystals press down on their sensory hairs with only a fraction of their usual force. The signals they send to your brain are now faint, ambiguous whispers. The result can be a profound sense of disorientation, a kind of persistent, low-grade vertigo, as if you are constantly walking on the deck of a gently rolling ship. Your brain, which has relied on these clear gravitational signals for your entire life, is now confused, and it must slowly, over days and weeks, learn to recalibrate itself. It must learn to trust your eyes more than your inner ear, and to understand that this new, gentle pressure is the new definition of down. Over the much longer term, this light world would begin to reshape the human body itself. For the first generation born on Mars, beings who would never know the full, heavy embrace of Earth, their bodies would grow and adapt in remarkable ways. Without the constant, compressive force of strong gravity, their spines might elongate, making them taller and more slender than their earthbound ancestors. Their bones would develop with a lighter, more delicate structure, perfectly adequate for Mars but dangerously brittle if they were to ever visit the planet of their origins. The heart, no longer needing to pump blood so forcefully against gravity, would likely be smaller and more efficient. Their entire physiology would be a testament to the principle of adaptation. They would be the first true Martians, a new branch of humanity, forged by a different world. They may even look upon videos of their ancestors on Earth with a kind of sympathetic wonder, watching them struggle against a crushing, invisible force, a force they themselves have only ever known as a gentle caress. But this newfound physical grace, this dreamlike, buoyant existence, is a fragile gift, enjoyed only within the sealed and pressurized confines of a suit. It is a constant, silent reminder that just beyond the thin visor of your helmet lies an atmosphere that is utterly and lethally unbreathable. Take a deep breath. Feel the air fill your lungs, the effortless, unconscious exchange of gases that sustains your life. It is the simplest and most vital act of our existence, a rhythm we have followed without thought since the moment of our birth. Now, imagine having to build that breath, molecule by molecule. On Mars, this is not a philosophical exercise. It is the fundamental challenge of survival. Inside the habitat, the first permanent human home on another world, the air you breathe is the most precious and complex creation of all. The overwhelming silence of the Martian landscape outside is replaced by the gentle, constant hum of machinery. It is the sound of life support, the whirring of fans, the quiet bubbling of filters, and the soft electronic clicks of sensors. This symphony of technology is the sound of your next breath being made. On a wall, a digital display shows the composition of the air, the numbers glowing a comforting green. Oxygen, 21%. Nitrogen, 78%. It is a perfect, manufactured replica of the air of Earth, a tiny, breathable bubble of home held within a thin metal shell. And the very existence of this air is a testament to a new kind of alchemy, a modern magic that turns a poisonous sky into a life-giving atmosphere. The raw material for this miracle is all around you. The Martian atmosphere, that thin, pinkish veil you see outside your window, is made of about 96% carbon dioxide, which we sometimes write as CO2. It is the very gas our bodies exhale as a waste product. For us, it is not just unbreathable, it is a poison in high concentrations. The challenge for the first colonists is not just to find oxygen, but to make it, using the abundant carbon dioxide as a resource. This is the core principle of what scientists call in situ resource utilization, or ISRU. It is a simple and powerful idea. Live off the land. To create a sustainable presence on another world, you cannot rely on shipping everything you need from Earth. The cost would be too great, the supply lines too long and fragile. You must learn to use what is already there, the soil, the ice, and the air itself, to create what you need to survive. It is the shift from being a visitor to being a resident. The key to this new alchemy lies in a remarkable piece of technology, a device that acts as the habitat's mechanical lung. An early version of this technology, called MOXIE, which stands for the Mars Oxygen In Situ Resource Utilization Experiment, was tested successfully on the Perseverance rover. You can think of it as a small, incredibly robust artificial tree. A tree on Earth inhales carbon dioxide, uses sunlight for energy through photosynthesis, and exhales oxygen. The MOXIE device does something chemically similar, but with electricity and heat. It begins by drawing in the Martian air and compressing it. Then, it pumps this air into a chamber, where it is heated to an incredibly high temperature, around 800 degrees Celsius, or nearly 1,500 degrees Fahrenheit. At this extreme heat, the carbon dioxide molecules, each made of one carbon atom and two oxygen atoms, become unstable. They are then passed through a system that uses a powerful electrical current, a process called electrolysis, which rips the molecules apart. The CO2 molecule is split into a molecule of carbon monoxide, or CO, and a single, pure, and very precious atom of oxygen. These oxygen atoms are then collected, combined into the stable O2 molecules we need to breathe, and stored. The carbon monoxide is vented back outside as a waste product. It is a slow, energy-intensive process, but it is a steady and reliable one. A small, microwave-sized device can produce enough oxygen for one person to breathe, while larger systems could generate not only breathable air for a whole habitat, but also the liquid oxygen needed to make rocket propellant for a return journey to Earth. We often imagine alchemy as the mythical quest to turn worthless lead into precious gold. But on Mars, we find a new, and far more profound, kind of transformation. It is the art of turning a deadly, suffocating gas into the very essence of life. It is the triumph of human ingenuity over a hostile environment. Every calm, easy breath you take inside the Martian habitat is a quiet victory, a product of incredible science and engineering. Each inhalation is a reminder that you are living in a place that was not made for you, but which you are remaking to make it a home. And as you stand there, in your bubble of manufactured Earth, breathing air that was once the red sky of Mars, you know that this is only the first step. With air to breathe, the next great quest begins. The search for the second ingredient of life, a molecule that is not in the sky above, but locked away in the frozen, dusty ground beneath your feet. Can a desert planet hold a hidden ocean? From your habitat on Mars, the world outside the viewport is a study in dryness. It is a planet of dust and rock, a vast, silent landscape carved by ancient forces, but seemingly untouched by liquid water for billions of years. Yet, the evidence of a wetter past is written everywhere upon its face. As you look at the high-resolution maps sent back by orbiting satellites, you can trace the ghostly outlines of features that are achingly familiar. You see the delicate, branching patterns of long dry riverbeds, the wide, sweeping fans of ancient deltas where great rivers once emptied into vast craters, and enormous outflow channels that speak of catastrophic floods on a scale that dwarfs anything in Earth's history. Mars whispers of a time when it had blue skies and rushing water, a time when it might have looked much more like a sister to our own world. The planet is a beautiful, heartbreaking relic of what it once was. And the great question for any new inhabitant is whether any of that ancient water, the single most essential ingredient for life as we know it, still remains. The answer, is a resounding yes. The water of Mars is not gone. It is merely in hiding. As the planet's atmosphere thinned over the eons, and its surface grew colder, the water that once flowed freely retreated. Some was lost to space, its molecules broken apart by solar radiation, but much of it simply froze. Today, vast quantities of water ice are locked away in the planet's polar ice caps, shining white against the red rock, though they are mixed with a great deal of frozen carbon dioxide, or dry ice. But the true treasure, the accessible reservoir for a fledgling colony, lies just beneath your feet. In the middle and higher latitudes of the planet, just a meter or two below the dry, dusty surface, lies a layer of permafrost, a mixture of soil and rock cemented together by pure water ice. This is the hidden ocean of Mars, a planet-wide subsurface glacier containing enough frozen water to potentially cover the entire globe in a shallow sea if it were ever to melt. The search for this water is the first great quest of exploration, a drilling operation that feels less like a geological survey and more like a sacred rite, a dowsing for the very possibility of a future. And the moment the drill brings up a core sample, not of dry red dust, but of soil sparkling with the unmistakable glint of ice crystals, is a moment of profound, life-affirming triumph. But even with this discovery, you cannot simply melt the ice and expect to have a pool of liquid water. On Mars, the rules of chemistry and physics are different, governed by the incredibly thin atmosphere. Here on Earth, we are used to water having three stable states: solid ice, liquid water, and gaseous vapor. You can watch an ice cube melt into a puddle, and then watch that puddle slowly evaporate. On Mars, the middle step is largely missing. The atmospheric pressure is so low that it is almost a vacuum, and this has a dramatic effect on the boiling point of water. It drops so low that liquid water is incredibly unstable. If you were to bring a block of pure ice out onto the Martian surface and warm it, it would not melt into a puddle. Instead, it would begin to fizz and steam, turning directly from a solid into a gas in a process called sublimation. It behaves just like a block of dry ice does on Earth. This is why Mars is so dry on the surface. Any ice that is exposed to the sun and warmed sublimates away, vanishing into the thin air. To capture the water of Mars, you must do so in a closed, pressurized environment. The process of harvesting this water is a masterpiece of engineering. A robotic excavator or a drill digs up the ice-rich soil and transfers it into a heated, sealed container. As the soil is warmed, the ice within it sublimates, turning into water vapor and filling the chamber. This vapor is then piped away and passed over a cold surface, where it condenses, turning from a gas back into a beautiful, pure, and life-giving liquid. This harvested water is the lifeblood of the new world. It is, of course, for drinking, for hydrating the bodies that are so carefully adapted to a water-rich planet. But its purpose is far greater than that. Through electrolysis, its molecules, the familiar H2O, can be split apart, yielding breathable oxygen for the habitat and hydrogen, which can be used as a primary component for rocket fuel. And most importantly, this water is the key to the most audacious challenge of all: agriculture. The search for water on Mars is therefore a search for our own reflection. It is the thread that connects this ancient, sleeping world to the possibility of a sustainable and then a thriving human future. It proves that the ingredients for a new beginning are already here, waiting beneath the dust, ready to be awakened. And with this newfound water comes the hope of coaxing the first hint of green from the sterile, alien soil. What does it take to convince a seed, a tiny vessel of terrestrial life, that a world without rain, without worms, without any living history, is a place it can call home? This is the central, poetic challenge of becoming a true Martian. After securing air and water, the next great task is to create a garden, not for beauty, but for survival. And so, the first Martian greenhouse is built, a great, transparent dome arching against the pale, pinkish sky. From the outside, it is a strange, alien jewel on the red landscape, but to step inside is to be transported back across millions of kilometers of empty space. The air is warm and thick with humidity, a stark contrast to the thin, cold atmosphere outside. The dominant color is no longer red, but a vibrant, hopeful green. And the light is not the pale Martian sunlight, but the intense, purplish-pink glow of countless light-emitting diodes, or LEDs, each one tuned to the specific wavelengths of light that plants crave for photosynthesis. The silence of the outside world is replaced by the gentle sound of dripping water and the hum of pumps. Tending to this garden becomes the most important ritual in the colony, a sacred duty. Watching the first green shoots of lettuce or potatoes push their way up from their nutrient beds is a miracle that will never grow old, a powerful affirmation that life has taken root in this most unlikely of places. This garden cannot be planted in the Martian ground itself. The soil on Mars, known as regolith, is not like the rich, dark loam of Earth. It is essentially crushed volcanic rock and dust, a sterile medium completely lacking in the organic matter and nutrients that terrestrial plants need to thrive. It is a ground that has never known decay, has never been enriched by fallen leaves or the work of microbes. Worse still, the Martian regolith is laced with a class of toxic salts called perchlorates. While not dangerous when locked in the soil, they would be harmful to both humans and plants if absorbed, and so the native regolith must first be carefully processed, or washed, to remove these compounds before it can even be considered for agricultural use. Early Martian farming, therefore, will almost certainly bypass the problematic soil altogether, relying on the advanced, water-efficient techniques of soilless agriculture. Two such methods would be the foundation of this new world's food supply: hydroponics and aeroponics. In a hydroponic system, plants are grown with their roots suspended not in soil, but in a shallow stream of flowing water. This water is a carefully controlled nutrient solution, a liquid feast containing every mineral and element the plant needs to grow. Delivered directly to its roots, it is an incredibly efficient system, using up to 90% less water than traditional agriculture because the water is not lost to the ground, but is constantly recycled and replenished within the closed loop of the greenhouse. An even more advanced method is aeroponics, where plants are grown with their roots hanging in the open air inside a sealed chamber. Every few minutes, a fine, nutrient-rich mist is sprayed over the roots, giving them exactly what they need without even the medium of water. These techniques would allow Martian colonists to grow crops with a speed and efficiency that would be the envy of many farmers on Earth, creating a reliable and controllable food source in a completely artificial environment. But even with water and nutrients, there is one more invisible ingredient from Earth that must be brought to Mars: a living ecosystem of microbes. The soil on our home planet is teeming with billions of bacteria and fungi in every handful, and many of these microscopic organisms live in a symbiotic relationship with plants. They help to break down complex materials into usable nutrients and protect the plant roots from disease. They are the invisible partners in the dance of life. A Martian greenhouse, being completely sterile to begin with, would need to be deliberately inoculated with these beneficial microbes. The first farmers would be microbial pioneers, carefully cultivating not just their plants, an entire microscopic ecosystem to support them. They would be recreating, in a small, sealed dome, the complex web of life that we take for granted on Earth. The first successful harvest on Mars, therefore, will be so much more than just food. It will be a symbol of breathtaking significance. It will be a declaration that life is not a phenomenon exclusive to one blue planet. It will prove that life, our life, with all its needs and its complex dependencies, is a force that can be carried outward, a seed of Earth that can be planted in the red dust of another world. And as we build these precious havens of green, living things, we must also perfect the art of building our own homes, shelters not just from the cold, but from the invisible, silent storms that rage across the Martian plains. How do you build a home where the walls must hold back a vacuum? After creating a garden of earthly life, you must perfect the art of creating a sanctuary for human life. A Martian home is more than a shelter from the cold. It is a fortress, a life support system, an ark, and a psychological refuge, all in one. The architecture of this new world will not be born from aesthetics, but from a brutal and honest conversation with the laws of physics. As you walk through the interconnected modules of your habitat, you are constantly aware of the thin, engineered barrier that separates you from a lethal environment. There are no large, picture windows. Instead, small, thick portholes of reinforced glass offer constrained views of the red landscape, reminders of both the beauty and the danger that lie outside. Much of your life is lived without direct sunlight, under ceilings that glow with a soft, artificial light, carefully tuned to mimic the 24-hour cycle of a terrestrial day, a comforting and necessary illusion of home. There is a palpable sense of being enclosed, of living within a ship that has permanently docked on a hostile shore. The safety of this enclosure is a marvel of engineering, a fragile bubble of life maintained by human ingenuity. The single greatest challenge that dictates the design of any Martian habitat is the constant, invisible threat of radiation. On Earth, we are protected by a planetary shield system, a powerful magnetic field, and a deep, thick atmosphere. On Mars, both of these are largely absent. The surface is perpetually exposed to the full, unmitigated onslaught of galactic cosmic rays and energetic particles from our own sun. The most effective shield against this kind of radiation is simple: brute force mass. The more material you can place between yourself and the sky, the safer you will be. This means that the first Martian homes will almost certainly be built underground, or at the very least, be buried under several meters of Martian soil. We will burrow into the planet for safety, like the earliest creatures on Earth seeking refuge from a harsh world. Colonists might expand natural lava tubes, ancient volcanic caves that are already shielded by a thick ceiling of solid rock, or they might use robotic excavators to dig trenches and then cover their inflatable or rigid habitats with a thick blanket of regolith. Your home on Mars might feel more like a cozy, well-lit burrow than a house, with the planet itself serving as the ultimate wall, a silent, earthen guardian against the dangers of the cosmos. The second great challenge is the immense pressure difference between the inside and the outside. Your habitat is pressurized with a breathable, Earth-like atmosphere, while the air outside is a near vacuum. This creates a constant, powerful outward force on every square centimeter of the habitat's walls. You are living inside an inflated balloon. The structural integrity of the walls must be absolute, because any significant puncture would not be a simple leak, but a catastrophic failure known as explosive decompression. The air inside would rush out with violent force, a disaster that would be over in seconds. This is why the habitats are likely to be made of resilient, multi-layered materials, perhaps composites of plastics like Vectran and other advanced polymers, designed to be incredibly tough and resistant to tearing. The structure itself would likely be a series of smaller, interconnected modules, each of which can be sealed off with airtight bulkheads, much like a submarine, so that a breach in one section does not compromise the entire colony. To build these buried, pressurized fortresses, it would be impossible to ship all the necessary materials from Earth. A single brick is a costly piece of cargo on a journey of millions of kilometers. And so, colonists will once again turn to the principle of living off the land. The future of Martian construction likely lies in advanced three-dimensional printing. Fleets of autonomous robots could be tasked with scooping up the abundant Martian regolith. This soil would then be mixed with a special binding agent, perhaps a polymer brought from Earth or even one that could be manufactured from Martian resources. This Martian concrete would then be extruded, layer by layer, to print entire structures, walls, radiation shields, landing pads, and roads. It is a vision of a slow, patient, and methodical construction, with robots as the masons of this new world, using the very dust of the planet to build the homes that will protect its new inhabitants. This architecture, born of necessity, will be a physical manifestation of humanity's relationship with Mars. It will not be about dominating the landscape, but about finding a safe and respectful place within it. Our homes will be our exoskeletons, our shells, our carefully constructed cocoons. And within these safe havens, another, more subtle kind of adaptation must take place. One not of the body, but of the mind, as it learns to live with the pervasive silence and the unending, soul-altering red of the horizon. Can the color of a world change the color of your thoughts? Within the safety of your Martian habitat, the greatest challenge shifts from the physical to the psychological. You look out through a small, thick porthole, or perhaps at a high-definition screen that displays the view outside. The landscape is majestic, alien, and profoundly, deeply monotonous. It is a world painted in a limited palette. The ochre and rust of the ground, the pale salmon of the sky, the shadows are sharp and black in the thin air. The horizon is a clean, simple curve, and it does not change. There are no clouds scudding across the sky, no birds in flight, no trees swaying in the wind. The only movement is the slow, predictable arc of the sun and the occasional, silent whisper of a dust devil in the far distance. It is a landscape of sublime and perfect stillness. And for a mind that evolved amidst the chaotic, vibrant, green and blue dynamism of Earth, this stillness can become a crushing weight. This is a phenomenon that psychologists who study people in extreme, isolated environments, such as Antarctic research stations or nuclear submarines, understand very well. The human brain is a novelty-seeking organ. It is wired to notice change, to respond to new stimuli, to process a constant stream of complex sensory information. When it is deprived of this rich input, when every day presents the exact same view, the same sounds, the same textures, the brain can enter a state of sensory starvation. This environmental monotony can lead to a host of psychological issues. A decline in cognitive performance, a flattening of emotions, irritability, and a deep, gnawing depression. The beautiful, stark landscape of Mars, so awe-inspiring at first, could slowly become a source of profound mental strain, an ever-present reminder of your isolation and the infinite distance from the sensory richness of home. To combat this, the colonists must become the architects of their own sensory world. They must fight against the encroaching red with curated, vibrant life. This is where the concept of biophilia becomes not just a hypothesis, but a critical strategy for survival. Biophilia is the idea that humans possess an innate tendency to seek connections with nature and other forms of life. It is the deep, instinctual satisfaction we feel when walking through a forest, listening to the ocean, or caring for a plant. On Mars, this connection to a living world is completely severed. And so, the greenhouses become more than just farms. They become psychological sanctuaries. They are the only places where one can be surrounded by the color green, by the smell of damp earth, by the sight of living, growing things. People would spend hours there, not just working, but simply being, recharging their minds with the biological vitality that the rest of the planet lacks. In addition to these real green spaces, they would rely on advanced virtual reality, allowing them to walk through a simulation of a lush terrestrial rainforest, or stand on a familiar seashore, a temporary but vital escape for a mind starved of home. This growing psychological separation from Earth would be reinforced by a subtle but powerful astronomical reality: the slow desynchronization of time itself. A day on Mars, which colonists would call a sol, is slightly longer than an Earth day, lasting for 24 hours and 39 minutes. This small, extra half hour and a bit might seem trivial, but its effects would be cumulative and profound. Colonists would have to adopt new clocks, new schedules, new rhythms of work and rest. Their morning would slowly drift out of sync with morning in London or Tokyo. Their entire culture would begin to operate on a different temporal pulse. This constant, creeping time shift would act as a powerful psychological wedge, making real-time connection with Earth impossible and reinforcing their identity as something separate, something new. They would become Martians, not just in place, but in time. And so, the first generation of humans on Mars will have to learn a new kind of mindfulness, a new way of seeing. They will have to find beauty not in variety, but in subtlety, not in chaos, but in stillness. They must learn to appreciate the slight shift in the color of the light as the sun sets, or the intricate patterns the wind carves in the dust. They will be the founders of a new human culture, a culture born of red dust and a profound, overwhelming silence. And that silence itself would be different, a thin and brittle quiet that changes the very nature of a whisper or a song. Imagine a world where a shout travels no further than a whisper. We are creatures of sound. Our languages are built from it. Our music is the art of shaping it, and our safety often depends on hearing it. The rustle of leaves, the crash of waves, the familiar cadence of a loved one's voice. These are the auditory textures of our lives. But sound, like life itself, is a product of its environment. And on Mars, the environment is thin, cold, and profoundly quiet. Inside your helmet or your habitat, the world sounds normal, a bubble of terrestrial acoustics created by technology. Microphones pick up your voice and play it back in your earpiece. Speakers broadcast the voices of your crewmates. But if you could stand on the surface and listen with your own ears to the world around you, you would experience a silence that is fundamentally different from any silence on Earth. It would be a muted, muffled world where sounds are born weak and die quickly, swallowed by the thin, unaccommodating air. A rock falling from a cliff 100 meters away might be completely inaudible, its impact a silent puff of dust. The Martian wind, unhindered by trees or buildings, would not be a deep roar, but a faint, high-pitched hiss, the sound of a few lonely molecules streaming past your helmet. The reason for this deep, planetary quiet is a simple matter of physics. Sound is not an object that flies through the air. It is a vibration, a pressure wave that is passed from molecule to molecule. For sound to travel, it needs a medium, something to carry the vibration along. The denser the medium, the more efficiently the sound can travel. On Earth, our atmosphere is a thick, dense ocean of nitrogen and oxygen molecules, packed tightly together. When you speak, you create a vibration that bumps these molecules into their neighbors, which bump into their neighbors, carrying the wave outward like a ripple in a pond. But the Martian atmosphere is incredibly tenuous, with less than 1% of the density of Earth's. There are far fewer molecules, and they are spread much farther apart. Trying to send a sound wave through the Martian air is like trying to swim through a light fog instead of water. There is simply not enough substance for the wave to effectively push against. The vibration struggles to propagate, its energy dissipating almost immediately into the near vacuum. Sounds would lose their volume with astonishing speed, fading away over just a few meters. This thin atmosphere also changes the speed at which sound travels. Here on Earth, sound moves at about 343 meters per second, a speed we have come to call Mach 1. On Mars, due to the extreme cold and the different chemical composition of the air, the speed of sound is significantly slower, only about 240 meters per second. This would create a strange and subtle disconnect between sight and sound. You would see a robotic arm move, and the sound of its motor would arrive a noticeable moment later, giving the world a slightly disjointed, sluggish auditory quality. And perhaps most strangely of all, the very character, or timbre, of sound would be altered. The Martian atmosphere is composed almost entirely of carbon dioxide, and CO2 molecules are particularly good at absorbing high-frequency sound waves. This means that sharp, high-pitched sounds would vanish almost instantly, while low, bass-heavy sounds would travel a little further. The entire soundscape of the planet would be filtered, as if a cosmic audio engineer had turned down the treble on the universe. A bird's high-pitched chirp would not survive a journey of a few feet. The world would be a place of rumbles and whispers, a muted, bass-dominated auditory environment. We cannot begin to imagine how living in such a world would shape us over time. Our languages, with their complex consonants and subtle inflections, are designed to be carried on Earth's accommodating air. Our music, with its soaring violins and shimmering cymbals, relies on the transmission of high frequencies. On Mars, we would live within a perpetual, natural muffle. How would this change the way we speak, the way we laugh? What kind of new music would be born in a world that favors the deep, resonant thrum of a drum over the delicate notes of a flute? We are shaped by our senses, and to live on Mars would be to have one of our most fundamental senses profoundly altered. The sonic world of Mars would sculpt our perception day by day, and this constant sensory pressure, this thin and brittle quiet, would be just one of the many forces that would, over the slow march of generations, begin to sculpt not just our culture, but the very code of our physical being, creating an entirely new branch on the human family tree. What happens when a child is born who has never known the feeling of full Earth gravity? This is the moment when humanity's journey to Mars transitions from an expedition to a true migration. The first child of Mars would be a creature of two worlds, a descendant of Earth, but a native of the Red Planet. For this child, the loping, graceful gait of low gravity would not be a learned skill, but an innate, unconscious movement. The pale, butterscotch sky would not be alien, but the simple, familiar color of home. The stories of Earth, passed down through generations, would sound like fantastical myths. A world of crushing weight, of suffocatingly thick air, of a sky so deeply blue it hurts the eyes, and of water that falls from the sky as rain. To this child, and all who would follow, Mars would not be a hostile environment to be endured. It would simply be the world, in all its stark and quiet beauty. They would be the first true Martians, and their very existence would signal the beginning of a profound and irreversible divergence of the human species. This divergence is not a matter of science fiction, but a simple, predictable outcome of the laws of evolution. The first principle at play is called genetic drift. In any small, isolated population, the frequency of certain genetic traits can change over time simply due to random chance. The founding population of Mars would be, by necessity, a tiny sliver of humanity's total genetic diversity. The specific blend of genes carried by those first 100 or first 1,000 colonists would be the entire genetic toolkit for a new world. By sheer chance, this toolkit would be different from the average on Earth. Over generations, without the constant mixing of genes from the larger terrestrial population, this small Martian gene pool would begin to drift, to wander down its own unique evolutionary path. The second, and more powerful principle, is natural selection. The Martian environment, with its low gravity, higher radiation levels, and enclosed habitats, would exert a unique and constant selective pressure. Any genetic traits that offer even a slight advantage for survival and reproduction in this new world would be more likely to be passed on to the next generation. Over the span of centuries and millennia, the results of this process would become visible. The children of Mars would be shaped by their world. As we have explored, their skeletons would likely develop to be taller and more gracile, their bones less dense, as a heavy, robust frame is a waste of resources in a low-gravity environment. Their cardiovascular systems, including their hearts, would adapt to the reduced workload. Perhaps, over a very long time, subtle adaptations to the higher background radiation might emerge. More efficient DNA repair mechanisms becoming more common in the population. The most poignant consequence of this adaptation is that these new humans would be uniquely, and perhaps permanently, Martian. Their bodies, so perfectly tuned to the gentle gravity of Mars, would likely be unable to withstand the full, crushing 1G environment of Earth. A visit to the planet of their ancestors would be a physical impossibility, a journey their bodies could not survive. They would be forever bound to their red world, the first true extraterrestrials of human origin. This biological separation would extend even to the invisible world within them. Each one of us is not a single organism, but a walking ecosystem, home to trillions of bacteria, viruses, and fungi that make up our microbiome. This complex community, mostly in our gut, helps us digest food, trains our immune system, and contributes to our health in countless ways. The first colonists would carry with them a diverse arc of Earth's microbial life. But in the sterile, isolated habitats of Mars, this internal ecosystem would begin to change. It would be cut off from the constant influx of new microbes from the Earth's environment. It would evolve in its own isolated petri dish, interacting only with the other colonists and the manufactured world around it. Over generations, the Martian microbiome would become its own unique entity, another distinct biological signature of their separation from Earth. To become a multiplanetary species, then, is to make a profound and humbling choice. It is to accept that our children, and their children's children, will not be just like us. It is an act of letting go, of planting a seed that we know will grow into a tree of a different shape. And these future Martians will not only be biologically different, their entire perception of reality, beginning with the passage of each and every day, will be forged by a different and slightly slower celestial rhythm. What if your day had an extra 39 minutes? What would you do with that small pocket of found time? It seems like a simple question, but on Mars, it is a profound and unyielding reality that reshapes the very rhythm of life. For all of human history, our lives have been tethered to the steady, predictable rotation of the Earth. The 24-hour day is the fundamental metronome of our biology, our society, and our souls. It is the silent, constant drumbeat to which we have always danced. But on Mars, the drum beats to a different rhythm. As you live and work in the Martian colony, the clocks on the wall do not measure the time of London or New York or Beijing. They measure the slow, stately progress of the Martian soul. You wake and sleep, work and rest, eat and dream on a schedule that is slowly, inexorably, drifting away from the world you left behind. This temporal separation is more than a mere inconvenience. It is one of the most subtle and powerful forces shaping the creation of a new and distinctly Martian human culture. A Martian solar day, or a sol, is the time it takes for the planet to complete one full rotation on its axis, so that the sun appears in the same position in the sky. This period is 24 hours, 39 minutes, and 35 seconds long. This extra bit of time, just shy of 40 minutes, is a constant presence in the lives of the colonists. At first, it might feel luxurious, a little extra space in the day, but its true effect is to create a constant, low-level form of jet lag, a permanent desynchronization between our internal, biological clocks and the external planetary clock. Deep within your brain, you have a master clock, a cluster of cells called the suprachiasmatic nucleus. This is the heart of your circadian rhythm, the internal pacemaker that has been finely tuned by millions of years of evolution to expect a roughly 24-hour cycle of light and dark. It regulates your sleep-wake cycle, the release of hormones like melatonin and cortisol, and even your body temperature. This internal clock is not perfectly rigid. It can be reset or entrained by external cues, primarily the rising and setting of the sun. This is why we can adapt to new time zones after a few days of travel. But on Mars, the sun is constantly trying to reset your internal clock to a 24.65-hour day, while your innate biology is stubbornly trying to stick to its 24-hour programming. This creates a persistent mismatch, a subtle but unending strain on the body and mind. It can lead to difficulties with sleep, fatigue, and a host of other subtle health issues. The first colonists would have to be incredibly disciplined, using carefully controlled light exposure inside the habitat to try to trick their bodies into adopting the longer Martian day. For some, it may be a constant struggle, but for those born and raised under this slower rhythm, the Martian sol would be the only beat they have ever known, their bodies and minds perfectly attuned to the long, gentle cadence of their home world. This new rhythm of life would necessitate a complete reinvention of how we measure time. Terrestrial calendars, with their months and seasons so perfectly tied to Earth's orbit, would become meaningless. The Martian year, the time it takes for Mars to complete one orbit around the Sun, is 687 Earth days long, or about 1.88 Earth years. Martian society would need its own calendar, with new names for the months, new holidays, and new seasons that would be longer and colder than any on Earth. A 7-sol week would feel natural, but how many sols would make up a month? How would they account for the long Martian year? These are not trivial questions. The creation of a calendar is a foundational act of any civilization. It is how a culture structures its past, present, and future. The Martian calendar would be a declaration of independence, a tangible symbol of their new identity. Our entire sense of history and progress is built upon the rhythm of the Earth's day and its journey around the Sun. On Mars, humanity would be forced to find a new pulse, a new and slower tempo for its ongoing story. And as the colonists look up from their new calendars and their slowly ticking clocks, their eyes would inevitably be drawn to the night sky, to a single, bright, and particular point of light, a star that is a constant, silent reminder of the faster, older rhythm they left behind. Have you ever felt truly homesick? Not for a house or a city, but for a whole world. On a clear Martian night, you can step out onto the regolith in your suit, or simply gaze out of the habitat's thickest viewport, and experience a feeling of profound, cosmic loneliness that is unique in all of human history. The stars here are magnificent, a tapestry of cold, hard points of light scattered across a blackness of absolute purity. Without a thick atmosphere to make them twinkle, they shine with a steady, unwavering intensity. The two small, potato-shaped moons of Mars, Phobos and Deimos, might be seen racing across the sky, tiny and swift, compared to Earth's stately lunar companion. But your eyes will always be drawn to one particular star. It is not the brightest in the sky, but it shines with a special brilliance, a clear, bluish-white light that distinguishes it from the others. It does not seem to belong to the cold, distant starfield. This point of light is the planet Earth, and in that tiny, fragile-looking spark is everything you have ever known as home. From the surface of Mars, the Earth behaves as an inferior planet, which simply means its orbit is closer to the Sun than Mars's is. This has a beautiful and poignant consequence for anyone watching the skies. It means that Earth will always appear to be close to the Sun. You will never see it high in the sky in the middle of the Martian night. Instead, it will be a morning star that heralds the dawn, or an evening star that lingers in the twilight after the sun has set. It is a constant companion to the sunrise and sunset, a bookend to the long Martian sol. To see it is a ritual. As the sun dips below the horizon, painting the thin, dusty air in shades of violet and blue for a Martian sunset, strangely enough, is blue. You would wait for the sky to darken just enough for that familiar point of light to emerge. And in that moment, the 400 million kilometers of empty space between the worlds seem to vanish and reappear all at once. The emotional gravity of that sight is impossible to measure. Every person you have ever loved every forest, every ocean, every song, every book, every mistake, and every triumph of our entire species is contained within that single, serene point of light. This experience would be a new, and perhaps more powerful, version of the overview effect. Seeing the Earth from orbit, as a swirling blue and white marble, changed the consciousness of the first astronauts. But to see it from another world, to see it shrink until it is no longer a world at all, but a star among other stars, is a different kind of revelation. It is the ultimate perspective on our place in the universe. It is the final, humbling confirmation of what the astronomer Carl Sagan so beautifully described as the pale blue dot. To see your home as a mote of dust, suspended in a sunbeam, is to understand, in your very bones, the precious and improbable nature of our existence. For the first colonists, this sight would be a source of both profound comfort and unbearable sorrow, a beacon of memory in the vast, dark ocean of the cosmos. It would be a nightly pilgrimage, a moment of silent communion with a world they can never again touch. And for the generations born on Mars, for the children who know only the red dust and the thin air, that pale blue star would become the heart of their mythology. It would be a legendary, godlike place in their sky, the world of their ancestors. They would tell stories about it, trying to imagine what it must be like to live under a gravity so strong it is like a constant weight on your shoulders, or to see a sky that is a deep, overwhelming blue. They would speak of a world where water is so abundant that it covers almost the entire surface in vast, salty oceans, and where it falls freely from the sky. These stories would create a culture of inherited nostalgia, a collective, mythical memory of a paradise they can never visit. The Earth would become their Eden, their Atlantis, their heaven, a perfect, imaginary world hanging forever in their twilight sky. To see our planet from this impossible distance is to understand that we had to leave it to truly appreciate it. It is no longer just our world. It is a light, a memory, a silent promise. And as the new Martians gaze upon that distant, beautiful beacon, it would inevitably inspire in them the most audacious question of all. Could they, and should they, ever attempt to paint their own red world a pale and living blue? If you were given a blank canvas the size of a planet, what would you paint? This is the question that will hang in the air for the generations of Martians who will look upon the distant blue star of Earth and feel the pull of an ancestral memory. They will live in their buried habitats, walk in their domed greenhouses, and breathe their manufactured air, but they will dream of a world where they could walk freely under an open sky. And so, the grandest and most audacious project in human history might begin. The terraforming of Mars. It is a dream of planetary engineering, of remaking a world in Earth's image. It would not be a project of years or decades, but of centuries and millennia, a slow, patient, and godlike act of creation. The first strokes on this planetary canvas would be almost imperceptible. Hardy, genetically engineered lichens and microbes might be released from the habitats, the first living things to attempt a life on the raw Martian surface. For generations, they might be the only change. Tiny, dark patches of life clinging to the rocks, slowly, painstakingly, beginning the work of producing the first few molecules of organic soil. But these are just the seeds of a much grander vision, a vision that begins not with life, but with warmth. The ultimate goal of terraforming is to create an environment where humans can exist without the need for life support. This means raising the atmospheric pressure, increasing the temperature, creating a breathable mix of gases, and restoring liquid water to the surface. The very first step in this colossal undertaking is to warm the entire planet. The key is to initiate a deliberate, controlled, runaway greenhouse effect. The Martian polar ice caps are a vast, frozen reservoir of carbon dioxide. If this CO2 could be turned from a solid into a gas, it would thicken the atmosphere dramatically. And a thicker CO2 atmosphere would be much better at trapping heat from the sun, which would warm the planet further, which in turn would release even more gas from the poles, creating a self-sustaining cycle of warming. To kickstart this process, future Martians could employ technologies of breathtaking scale. They might construct giant, ultra-lightweight mirrors in orbit around Mars, focusing the faint sunlight and directing it into concentrated beams to heat the polar caps. Or they might build automated factories on the surface, robotic alchemists designed to pump man-made super greenhouse gases, like perfluorocarbons, into the thin air. These gases are thousands of times more effective at trapping heat than carbon dioxide, and a relatively small amount could begin to raise the planet's temperature significantly. As the planet slowly, over centuries, begins to warm, the second phase of the Great Transformation would occur. The rising temperatures would sublimate not just the carbon dioxide ice, but also the vast quantities of water ice locked in the poles and beneath the soil. Water vapor is itself a powerful greenhouse gas, and it would join the carbon dioxide in the thickening atmosphere, accelerating the warming even further. As the atmospheric pressure increases, it would eventually pass a critical threshold, the point at which liquid water can once again be stable on the Martian surface. This would be a moment of profound planetary rebirth. The first trickles of meltwater would begin to flow in the ancient riverbeds. Canyons and craters in the low-lying northern plains would slowly, over millennia, begin to fill, forming the first Martian lakes and seas. The world would turn from a dry, dusty red to a world of mud and mist and shallow, briny oceans. With a thicker atmosphere and liquid water, the final and longest phase could begin, making the air breathable. This would be the work of biology. The new Martian seas could be seeded with genetically engineered cyanobacteria, the same family of organisms that first oxygenated Earth's atmosphere billions of years ago. These microscopic life forms would perform photosynthesis on a planetary scale, slowly, molecule by molecule, converting the rich carbon dioxide atmosphere into breathable oxygen. This process would take thousands, perhaps tens of thousands, of years, a slow, planetary exhalation of life. This dream of a blue Mars, a new Earth, is perhaps the ultimate expression of human hope and ingenuity. But it is also an act of staggering hubris, and it raises a deep and difficult ethical question. Do we have the right to erase a pristine, 4-billion-year-old world to satisfy our own needs? The stark, silent, red Mars has its own profound and ancient beauty. It is a geological museum, a perfectly preserved record of the early solar system. To terraform it would be to destroy that history forever. Does a world have intrinsic value, even without life? Is it our place to overwrite its quiet, alien majesty with a familiar, terrestrial song? These are the questions that will be debated by the philosophers and poets of the new Martian society. They will have to weigh their own survival and expansion against the preservation of a world that is not, and never was, truly theirs. It is the greatest moral dilemma a species could ever face. And what if, in the midst of this great debate, in the process of drilling and digging and reshaping their world, they discover that they were never truly alone there to begin with? What if the deepest silence in the solar system was hiding a secret? For centuries, humanity on Mars would live with the knowledge that they are the sole representatives of life on their world, a small, fragile colony of biology in a vast, sterile desert. But as their science and technology grow more advanced, their search for knowledge would inevitably take them deeper, far below the cold, irradiated surface. Imagine a geological expedition, centuries from now, in a deep canyon near the Martian equator. They are not searching for water or minerals, but for something far more profound. They are drilling a core sample, their instruments biting down kilometers into the Martian crust, to a depth where the planet's faint internal heat might just be enough to sustain a pocket of briny, liquid water, a hidden aquifer that has been isolated from the surface for billions of years. The drill returns to the surface, and the precious core sample is taken to a laboratory. The initial analysis is tantalizing. The sample is rich in complex organic molecules, the chemical building blocks of life. This is a monumental discovery, but it is not yet proof. And then, under the immense power of an electron microscope, a scientist finds it. A tiny, fossilized, mineral-replaced structure. It is segmented, elongated, and unmistakably resembles the form of a terrestrial bacterium. It is an echo, the petrified ghost of a life that once was. The scientific basis for this search is strong. On Earth, we have learned that life is incredibly tenacious. It does not just exist in the gentle sunlit places, but thrives in the most extreme environments imaginable. We call these hardy organisms extremophiles. There is life huddled around the scalding, chemical-rich waters of volcanic vents on the deep ocean floor, in complete darkness and under crushing pressure. There is life frozen inside the ancient ice of Antarctica, dormant but still viable. There is life that thrives in the acidic waters of mine drainage and in the hypersaline environment of the Dead Sea. The discovery of these creatures has completely rewritten our understanding of where life is possible. If life can hold on in such punishing niches on Earth, it stands to reason that if life ever did get started on Mars, during its warmer and wetter past, it might have followed the water, retreating deep underground as the surface became a cold, dry, irradiated desert. The search for Martian life is not a search for little green men on the surface, but a patient, geological hunt for extremophiles, either living or fossilized, in the deep, dark, hidden corners of the planet. The discovery of even a single, unambiguous fossil of a Martian microbe would be the most profound and world-changing discovery in the history of science, and perhaps in the history of humanity itself. For our entire existence, we have wrestled with a fundamental question. Are we alone? Life on Earth, in all its spectacular diversity, can be traced back to a single common ancestor. It is one magnificent, solitary tree of life. Because of this, we have never been able to answer whether life is a bizarre, miraculous fluke unique to our planet, or a common and natural outcome of the laws of chemistry and physics. The discovery of a Martian life form, a second genesis, a completely independent tree of life, would answer that question in an instant. It would mean that the universe is not sterile, but seeded with potential. It would prove that the emergence of life is not a 1 in a trillion miracle, but a cosmic imperative, something that happens wherever the conditions are right. This would transform every field of human thought. Biology would become a comparative science, studying life as a universal phenomenon. Philosophers and theologians would be forced to reconsider humanity's place in a universe that is suddenly revealed to be not empty, but filled with a silent and perhaps ongoing biological hum. We would no longer be a lonely accident, but members of a vast and unseen cosmic community. The silence from the stars, the famous Fermi paradox, would seem even more puzzling, but the knowledge that we are not the only life to have ever existed would change our perspective forever. It would transform our story from one of solitary travelers in a great, dark emptiness to one of members of a universe that is, in its very fabric, alive. The fossil in the microscope would be more than a scientific curiosity. It would be a mirror, reflecting our own biological heritage and showing us that we are part of something much, much larger. And it would enrich the culture of the Martians themselves, giving their new world a deep and ancient history that predates their own arrival. Whether they find such a profound echo of ancient life or not, the new Martians will still be tasked with creating their own story, forging a new history, not just of scientific discovery, but of memory, of art, and of myth. How does a story begin on a world with no ancient history? On Earth, our cultures are built upon foundations thousands of years deep. We have the myths of the Greeks, the legends of the Norse, the epic poems of ancient India. We live in a world rich with the stories of those who came before. But on Mars, there are no ancient ghosts, no sacred groves, no ancestral burial grounds. The planet's only history is one of geology and silence. And so, the new Martians will have to create their own history, their own stories, their own sacred traditions, from the very beginning. Far in the future, in a vast, domed city filled with the soft purple light of Martian agriculture, you can imagine an elder telling stories to the children of the 5th or 6th generation. To these children, born and raised in the light gravity, Earth is a distant, magical place they know only from videos and tales. And the elder, in the timeless tradition of all human cultures, is weaving the factual history of their settlement into the fabric of myth. The long, 7-month journey through space is not described as a feat of orbital mechanics, but as the great crossing of the void. The first astronauts to land are not just historical figures. They are the first ones, the seed planters, figures of legendary courage and wisdom who brought the spark of life from the blue star to the red world. The first habitat is not a piece of engineering. It is the first womb, the sacred place where humanity was sheltered and nourished. The struggle to extract water from the ice and oxygen from the air becomes an epic battle against the sleeping red giant of the planet itself. The great volcanoes of the Tharsis region, like Olympus Mons, the largest in the solar system, become the homes of their new gods. The vast canyon system of Valles Marineris is not a geological rift, but the scar left behind by a mythical beast in a primordial age. This is how culture is born. It is the process of taking the raw, factual data of existence and infusing it with meaning, with metaphor, and with a sense of the sacred. This new culture would also develop its own unique voice. Language, like a living organism, evolves. And when a small population is isolated, that evolution happens much more quickly. The language of the first colonists, whatever it may be, would begin to change, to adapt to its new home. New words would need to be invented for uniquely Martian phenomena. A colonist might complain of soul lag, the persistent mental friction caused by the different day length. They might describe the sound of the wind as a dust hisses, or the particular shade of the evening sky as blue dusk. The English of Mars, after a few centuries, might have a different accent, a different cadence, shaped by the thin, muted soundscape of the world and the isolation of the community. Slang and idioms would develop that would be completely unintelligible to a person from Earth. Over 1,000 years, this linguistic drift could be so significant that Martian English could become its own distinct language, as different from its terrestrial ancestor as Spanish is from Latin. A person from Earth and a person from Mars might one day need a translator to understand one another. This shared, unique mythology and this shared, unique language would be the twin pillars of a new human identity. They would be the forces that would bind the colonists together and define them as something new. They would no longer see themselves as displaced Earthlings, but as native Martians. Their allegiance would be to the red dust beneath their feet, not to the distant blue light in their sky. Their stories would give them a shared past, their language would give them a shared present, and their collective struggle would give them a shared future. We would be witnessing, on a planetary scale, the birth of a new branch of civilization, complete with its own art, its own music, its own dreams, and its own soul. It is an almost unimaginable sociological and anthropological event, a chance to see how humanity begins again, on a fresh, clean slate. And perhaps, in the grand sweep of their new epic myths, in the tales they tell their children about the Great Crossing, they will finally find the truest answer to the question that started it all, a question that echoes back across the silent, empty millions of kilometers of space to the world where it all began. In the end, after all the science and all the struggle, what is the one thing you would carry with you to a new world? It is the final, and perhaps the most important, question. Imagine, for a moment, a single human being, a descendant of this long journey, generations in the future. She stands on the rim of a great Martian canyon, perhaps Valles Marineris itself. The air is still thin and cold, but it is breathable now, the product of millennia of slow, patient terraforming. The sky above is a pale, hazy blue, not as deep as Earth's, but a familiar and comforting sight. Below her, a trickle of real, liquid water, salty and cold, makes its way through the ancient riverbed. She feels the gentle gravity, a force her body understands as normal. She is at home. In the fading light of the evening, she looks up and sees it, the bright, unwavering blue-white star of Earth, the mythical home of her ancestors. And in that quiet moment of reflection, she represents the culmination of this entire audacious story. She is the answer to a question asked long ago. From her new vantage point, she would look out at the silent, star-filled cosmos and have a unique perspective on the great, unanswered question of the Fermi paradox. If the universe is teeming with the potential for life, then where is everybody? The silence would feel just as deep from Mars as it does from Earth. But her very existence would be a powerful piece of evidence in that cosmic debate. She would be proof that life is not necessarily trapped on its planet of origin. She would be proof that a species can learn to carry its precious, fragile spark of consciousness from one world to another. Her presence on Mars might suggest an answer to the paradox. Perhaps life is common, but the leap between worlds is simply incredibly difficult and rare. Or perhaps we are just the first to do it in our corner of the galaxy. She might feel a sense of profound responsibility, a feeling that humanity has lit a second candle in a vast dark room, and that it is her generation's sacred duty to keep that flame from flickering out. But the reasons for this journey, she would know from her myths and her histories, were always twofold. The first was a matter of simple, practical survival. To keep all of humanity on a single planet, however beautiful and robust it may seem, is to run an unacceptable risk. It is like storing all of your irreplaceable memories, all of your precious data, on a single, fragile computer with no backup. A single, catastrophic event, a large asteroid impact, a runaway plague, a self-inflicted environmental collapse could mean the end of everything. Spreading to Mars, and one day, perhaps, to worlds beyond, is the ultimate insurance policy. It is the act of backing up the hard drive of life itself, of ensuring that the 4 billion-year-old story of terrestrial consciousness does not have to end in a single, tragic moment. It is the most logical and responsible thing a species can do, once it has the power to do so. But beyond the logic of survival, there has always been another, deeper, and more spiritual driver. It is the innate and unquenchable human desire to explore. It is the restlessness that is woven into our very DNA, the curiosity that compels us to look over the next hill, to cross the next ocean, to ask, again and again, what lies beyond. It is the same spirit that drove our distant ancestors to walk out of Africa and spread across the globe. It is the same spirit that built the ships that crossed the Atlantic, and the same spirit that built the rockets that first took us to our own moon. The journey to Mars is simply the next, logical step in that ancient and noble human pilgrimage. We go not just because it is a prudent choice, but because it is in our very nature to reach, to strive, and to see what is on the other side. And so, as our story comes to a gentle close, we can finally understand that the destination was never truly the point. Mars was not the prize. The prize was the journey itself, the act of reaching, of learning, of becoming something more than we were. The great question that humanity carried with it across the void was not, can we do this? But rather, who will we become when we do? And the answer is written in the sky of a new world, in the eyes of its children, and in the beginning of a story that is now, and forever will be, part of the stars. Thank you for joining me on this long and gentle journey tonight. I hope it has brought you some measure of peace and wonder. If you have enjoyed our exploration, please do consider liking this video and subscribing to the channel. It means the world to us, and helps these stories find their way to others who might be seeking a quiet moment. I wish you the most peaceful and restful of sleeps, filled with gentle dreams of red deserts and pale blue stars. Good night.